Good morning, students. So in the last class, we have started discussion on the external communication interface, which can be used in an embedded system, and we have seen the details of RS-232C. So today, let us study one more external communication interface that is called as Universal Serial Bus (USB). Okay. So this Universal Serial Bus (USB) is a wired high-speed serial bus. So serial communication takes place in this USB, and it is a wired means of communication. So this USB was mainly designed to provide an universal means of communication between any two communicating entities. And also this USB is a host initiated data communication method. That means there will be host controller and number of other peripheral devices get connected to the host with the help of a USB cable. So this USB was designed by combined effort of companies such as Intel, IBM, Microsoft, etc. Okay, so these MNC companies, they work together to bring up this USB. So the USB has different versions. The earlier version of USB was USB 1.0, which was released in the year 1992. Okay, then came the next version, that is USB 2.0. So this USB 2.0 allows up to 127 devices to be connected to the host USB device. Okay, and the maximum USB cable length that you can use in this USB 2.0 specification is up to 5 feet. Okay, so the different versions of USB that are available are: the earlier version was USB 1.0. USB 1.0 allowed speeds of data up to 1.5 Mbps and 12 Mbps. Okay. Again, in this USB 1.0, we have USB 1.0 supporting 1.5 Mbps, and there is one more version that is called as USB 1.1 that allowed data rate of up to 12 Mbps. Then came the next version, that is USB 2.0. So this USB 2.0 allowed data transfer rate of up to 480 Mbps. Then came USB 3.0. So the speed of data transmission in this USB is 5 Gbps, and also the higher versions in this USB 3.0 allow the data transfer up to the rate of 10 Gbps. Okay, so these are the different USB versions that have come up. Okay, and this is how an USB cable looks like. Okay, already many of you have seen this USB cable. Okay, so this is called as the Type A connector in USB cable. This type of connector is called as Type A, and this connector, Type A connector, gets connected to the host controller. That may be your embedded system, or it may be, in general, it is a computer. Okay, so this Type A connector gets connected to the USB port of the computer or embedded system, and the other end of this USB cable will usually have another type of connector, that USB connector, that will be either Type B or Type C. And here this is a mini Type B connector. Okay, so one end it will have the USB cable, will have Type A connector. The other end will have Type B or Type C connector. Okay, so it is very rare that both the ends will have Type A connector. Okay, so just remember, one end will have Type A, other end will have either Type B or Type C connectors. And for increasing the number of the USB ports in any device, okay, to the host controller, we can use this USB hub. Okay, so this USB connector gets connected to the USB hub, and with the help of this single port, again 4 more ports have been made available. So you can connect other devices, and if you connect 3 devices to these 3 ports, and if you use one more hub, again 4 more ports will become available. So in this way, we can increase the number of USB devices that can be connected to the host controller. But remember, in USB 2.0, the number of such devices that can be connected to an USB host controller is up to 127 devices. Okay. Now there are different types of connectors, as I told you, in USB. So this type of connector is called as Type A. Okay, this Type A connector gets connected to the host controller or to the computer. Okay, the other end of the cable will have other type of connector, that is, it will have either Type B connector or it will have Type C connector, as you can see here, Type C. Okay, again in this Type A and Type B, there are again different types available, that is called as Type A Mini, Mini Type A or Mini Type B is available, as you can see here. Again, there will be Micro Type A and Micro Type B connectors available. Okay, so these are the different types of USB connectors which are available for connection. Okay. And this USB cables, inside it will have 4 pins. Okay. So the first pin is the 5 volts power supply. Okay. This one, first pin, 5 volts power supply will be there. Then the second and third pins will be used for data transfer. So this is denoted as data plus and data minus. So this notation stands for differential data transfer. That is, data will be transferred on both the lines here, both the wires. So this helps to increase the immunity of the data transmission against the noise. If there is any noise gets added, it will be added to both the sides. So at the end, other end, receiving end, the differential data remains the same. So in order to increase the noise immunity of the transmitted signal, this differential data transfer has been used in USB cables. Okay. So this pin number 2 and 3, they indicate what? The differential data minus and data plus. And the fourth pin is denoted as the ground signal. Okay. That is for the power supply. Okay. The same thing is available. This is type A cable and this is type B cable. Okay. You can see here the positive supply, D minus, D plus and the ground signal. Okay. So this is how the internal connections of the USB cable look like. So let us go through a small video to understand in detail about the USB.
Hello everyone. In this video, we're going to talk about the USB port, cables, and connectors. Now USB stands for Universal Serial Bus. The USB is the standard that is used to connect peripherals to a computer, and it's by far the most commonly used port. And the reason why it's so commonly used is because, just like its name says, it's universal. The USB port is used to connect many different kinds of devices, such as keyboards, mice, cameras, printers, scanners, external hard drives, flash drives, and it can even do networking and so much more. And it's also used to charge devices such as cell phones. And desktops and laptops will have several USB ports. Now, the goal of the development of the USB was to make connecting devices to a computer much easier. And this is done by first making one standard connector, therefore eliminating all the other different kinds of connectors. And second, by making connected devices easier to configure. And third, to provide fast transfer rates. The USB port is also hot swappable, so devices can be connected or disconnected without turning off the computer or the device. The USB also self-configures itself, which eliminates the need for any extensive configuration or no configuration at all. And in addition to connecting to a computer, certain smaller devices can be powered by the USB port without the need for additional power cables. The first USB version was released in 1996, starting with USB 1.0, with later versions released throughout the years. Now, USB 1.0 had a transfer speed of 1.5 megabits per second. Then 2 years later, in 1998, USB 1.1 was released, and this had a transfer speed of 12 megabits per second. Then in the year 2000, USB 2.0, which is also known as high-speed USB, was released. And this had a significant speed upgrade from USB 1.1, with speeds of 480 megabits per second. And then in 2008, USB 3.0 was released, and this was known as super speed USB. USB 3.0 boasts speeds of 5 gigabits per second. The high-speed increase was meant for transferring large amounts of data, such as backing up to external hard drives. Now, subsequent releases of USB 3.0 was later released, such as USB 3.1, which was released in 2013, and this is also known as Super Speed Plus. USB 3.1 had a transfer rate of 10 gigabits per second, which is double of USB 3.0. Then soon after, USB 3.2 was released, which had a transfer rate of 20 gigabits per second. And in 2019, USB 4 was announced, and this has a transfer rate of 40 gigabits per second. Now, in addition to the different speeds of USB, there is also different types of USB cables, connectors, and ports that it uses. Now, USB cables will typically have two different connectors on each end of a cable. They will have either Type A, Type B, or Type C, with the Type A connector on one end and B and C type connectors on the other end. Now, the Type A connector is the host connector. This is a standard rectangular plug that you would plug into a computer, and computers will have several Type A USB ports. And even though this is the oldest connector type, it is still being used today. Now, on the other end of the USB cable, you might find different types of connectors, such as the Type B connector. The Type B connector is a square design with beveled corners on top. Now, this is also an older connector, but it's still being used today. This type of connector is what you would plug into most printers today, but it's also used on other devices, such as external hard drives, USB microphones, and so on. And another version of a Type B connector is the Mini B. And just like its name says, it's smaller than a Type B connector. The Mini B is used on smaller devices, such as older smartphones and digital cameras. But it's being phased out in favor of even smaller connectors. And that brings us to the Micro B USB connector. The Micro B is approximately the same width as the Mini B, but it's about half the thickness, which enables it to plug into even smaller and thinner devices. It's made to connect to modern smartphones, modern digital cameras, MP3 players, and so on. The Micro B came out in the year 2007, and its intent was to replace the Mini B. There is also the USB 3.0 Type B connector. The Type B 3.0 has 9 pins compared to 4 pins in the previous versions, and this allows for higher transfer speeds and to supply power to a peripheral. Now, to make room for the pins, the Type B 3.0 is larger and has a different shape than the 1 and 2.0 versions. So, the Type B 3.0 connector will not fit into devices that are made for USB 1 and 2.0 because of its larger size. There is also the USB 3.0 Micro B, and this connector is just as thin as the 2.0 version, but it's wider. It's basically a USB 2.0 Micro B connector, but with 5 additional pins that are stacked on the side of the connector, which doubles the width of a 2.0 Micro B. This connector is used to carry data and supply power to devices, such as modern external hard drives. And in 2014, USB-C was developed, and it was developed with the USB 3.1 standard. Now, this is a thin connector with rounded edges, and it has 24 pins. And it easily plugs into a port because it doesn't have an up and down orientation. Today, the USB-C can be found on modern smartphones, external hard drives, tablets, and modern desktop and laptop computers. In fact, it's even used to charge larger devices, such as modern laptops. Now, as I stated earlier, typically USB cables will have different connectors on each end, with the Type A at one end and a different type on the other. However, a standard USB Type-C cable will have the same connector on each end because the Type-C can be connected to a host, meaning a computer at one end and connected to another device on the other end. So this makes a Type-C cable convenient because you don't have to figure out which end goes where, because it doesn't matter. Both ends are the same. But even though that's the typical USB Type-C cable, you will still find USB cables with Type A at one end and Type-C on the other end. Now, USB ports are color-coded, which determines what version they are. Now, as I mentioned earlier, a computer will have several USB ports and will typically have different versions, and that is determined by the computer's motherboard. So here is an example of the rear input-output panel of a desktop motherboard, and as you can see, it has several USB ports with different colors. Now, USB 1.0 and 1.1 ports will have a white color. Now, these ports are old, slow, and outdated, and you won't find them on modern motherboards anymore. USB 2.0 ports will have a black color, and even though they came out in the year 2000, you will still find them on motherboards today. USB 3.0 ports will have a blue color, USB 3.1 will have a teal color, and USB 3.2 ports are red. Now, there are also ports that are called sleep and charge ports, and this means that they will still supply power even if the computer goes into sleep mode, which means you can continually charge a device such as a cell phone even if the computer goes to sleep, which is convenient. And these ports will either have a red, orange, or yellow color. So thank you everyone for watching this video. Please subscribe, and I'll see you on the next video.
So we have seen the details of the USB communication. Okay. So just remember, this USB cable, with the help of this USB cable, the peripheral devices can be connected on the board. That is, you can plug and play, hot plug and play. Hot plug and play means you can connect any USB device to a computer or to an embedded system without requiring the computer or the embedded system to be shut down. Okay. Even when the computer or the embedded system is on, I can connect any peripheral using the USB cable to the computer or the peripheral, and I can start using that peripheral. Okay, that is called as hot plug and play. And using this USB cables is very much convenient compared to the RS-232C cable. Okay, so this is all about your universal serial bus communication interface. So let us next go to one more type of external communication interface, that is called as infrared communication. Okay, so already we use this infrared communication in our homes. Okay? We have the televisions in our house and we have the remote to change the channels or increase the volume, etc. So here the communication between the remote and the television takes place via the infrared light. Okay, so this infrared light allows serial half duplex communication. Okay, so there is a half duplex communication, that is the data will either flow from one side to other side, but not at the not in bidirectional at the same time. Okay, just remember. And also one more important point you have to remember about this infrared communication is it is the line of sight communication. That means the transmitter and the receiver should be visible to each other. Okay, then only the communication can take place. Okay, so the typical range that is allowed in infrared is from 10 centimeter to up to 1 meter. Okay, and the typical data transfer rate in infrared communication is from 9600 bits per second to up to maximum 16 Mbps. Okay, so for infrared communication, any device, okay, will have two parts. One is called as a transmitter and a receiver. A transmitter will have infrared LED that emits the infrared light, and the receiver will have the photodiode that will receive the infrared light. Okay, so there may be some devices which may have only transmitter. For example, our remote control, it has only transmitter. It will only transmit the signal to the television. And there will be some devices which will have only receivers. In our television, we have only the remote signal receiver, that is called as receiver. Okay, so in television there is no need for transmitter. In the remote there is no need for receiver. So there will be some devices which will have only transmitters and some other devices that will have only receivers. And there may be sometimes the devices want to send and receive the data using this infrared communication. Then such kind of devices will have both transmitter as well as receivers. So such units are called as trans receivers. Okay, trans receivers means it will have both transmitter as well as receiver. Okay, so remember this infrared communication. Okay, this is used for file transfer and for data transfer in case of low cost devices. Okay, so this is all about your infrared communication. Thank you.